Hello everyone. So in this video lecture we are going to understand the concept of minimum spanning tree. So as you are aware of that, minimum spanning tree is one of the shortest path algorithm in a graph. To understand this, first we need to understand what is spanning tree. So if I tell you that suppose you have a connected and directed graph, right? So spanning tree is a subgraph of that particular graph, which is particularly a tree that connects all the vertices together. So let me explain you with an example. So let us say I'm having this graph, and all the vertices are connected to each other. So this is my undirected graph, right? So if I talk about a spanning tree, so spanning tree, it's a kind of a tree. That means it does not contain any cycle, right? But what should be the thing, that all the vertices should be connected, right? So let me give you example of this, that suppose I'm having this. So my spanning tree can be something like this. If I join this A and E, then it will generate a cycle, right? So this is one of my spanning tree. Then if I talk, there can be multiple spanning tree, right? So for this I can have something like this as well. There can be a number of spanning trees, right? The only thing you need to keep in mind, then for a spanning tree there should be no cycle, and each vertices should be connected, right? So there should be a reachability to each the vertices, right? So this is like a spanning tree 1, this can be a spanning tree 2, then I can have something like this as well, right? This is my third spanning tree, right? So there can be a multiple spanning tree for a particular graph, right? Now here we are talking about minimum spanning tree. So what is minimum spanning tree? So for that, we should assign the weight to each of the edge, because it is for the weighted graph. If I talk about a minimum spanning tree, so it must be a weighted graph. Then and only then we can apply the algorithm of minimal spanning tree, right? So we need to assign that weight to a particular edges, and for a particular spanning tree, suppose this is my spanning tree 1, I need to count the total weight, right? So I need to sum up the weights available in that ages, right? And whatever is minimum, right, that could be my minimum spanning tree, right? So let us say this is like, if I'm giving this 3 2 1 2 7 2 3 1 5, right? So if I calculate here, so this is 3, this is 5, this is again 3, this one is 7, and this one is 2, right? So if I calculate, so it's a 3 2 5 5 10 10 and 20. So for this total weight is 20, right? Similar way I need to count for this. So this is 1 2 1 2 and 7, right? So this is 13. For this it's a 3 5, this one is 1, this one is 2, and this one is 7. and this would be 18, right? So this way you need to find the like a span weight of each the spanning tree, and whatever is having minimum, right, the weight should be lesser than or equal to the weight of every other spanning tree, right? It might be possible there might be a possibility of two minimum spanning tree, because if there is a repetition of weight, it might be possible, right? So that you need to keep in mind. Now finding this in such a manner, it's a quite difficult task, right? So we need for that, for finding the MST, we need to apply few of the algorithms for finding the MST. So we'll discuss it in the next lecture, but in this lecture I'll explain you that this is a roughly I'll take a shorter one graph, so I'll explain you all the possibilities, right? So let us have one graph over here. I'm taking smaller graph so I can explain you the all the possibilities, right? So you will easily get an idea that what is spanning tree and what is minimum spanning tree, right? So suppose this is my weighted graph. Now if I go for a spanning tree, right, so if I go for spanning tree, I can have this one. The only thing you need to keep in mind that there should not be a cycle, and each vertices should be reachable, right? There's two things you need to keep in mind, right? So this is my first possibility, right? Then another possibility I can have is something like this. For this also, like 2, 4 and a 3, right? Then another possibility I can have this something I can connect to this. So this is my another possibilities. Then I can go reverse of this. Here I'm showing each of the possibilities, right? And then we'll find which one is the minimum. And then in the next lecture we go for the algorithm. So it would be easy that step by step you will get an idea that what is minimum spanning tree and how to apply the algorithm and how you can go for the stuff. See, these are the 6 possibility. Now few more possibilities you can have. This is also one kind of possible. I need to check where I'm not repeating the stuff. No. So these are the possibility. It might be possible you will get something else, right? But these are the possibility whatever I am considering. Now this I can go for A to D, and then I can go for this, right? So this is 7, this one is 5, and this one is 3, and reverse of this one. So yeah, we can go with this. Okay, so I hope I drawn all the possibilities. If you find any more possibility, then do let me know, right? Now for these 9 possibility, if we calculate the cost, right? So for this it's a 7 plus 5, that's 12. For this it's a 9. Here we have 7 plus 6, 13, and 2, 15. Then for this 10. Then this is 6 and 5, 11. For this again 11. For this it's 7, 3, 10, 14. This is 12 plus 3, 15. And this one is 11, 3, 14. Yes, okay. So as you can see, among this is 12, 9, 15, 10, 11, 11, 14, 15 and 14. The minimum number is this 9, right? So you can say that this is your minimum spanning tree, right? These all are the spanning tree, but the minimum spanning tree is this, right? Here you have also seen that the these two graphs, sorry, these two spanning tree are different, but that cost is same, right? Here also these two spanning tree is different, right? But their cost is same. So it might be possible for some scenario that there might be a two minimum spanning tree, but that's very rare. If you have the same number or same weights, then it might be possible. So you just need to keep in mind that all you need to just calculate the weight of all the spanning trees, and those tree which have the lesser cost or equal cost to the other one, right? The lowest value, if that lowest value, like two of your spanning tree is having the lowest value, then both of them would be considered as minimum spanning tree. Otherwise the lowest value can have, we can consider it as a minimum spanning tree, right? So I hope you understood at the concept of minimum spanning tree, that how to draw the spanning tree and how to count the minimum spanning tree. In the next video lecture, we are going to understand the concept, the algorithm for finding the minimum spanning tree, right? There are basically two algorithms, right? Prim's algorithm and Kruskal's algorithm for finding the minimum spanning tree. So in the next video lectures, we'll one by one go for with the both Prim's and Kruskal's algorithm, right? Along with the algorithm, I'll explain you the examples as well, so you will get the idea. So till that, thank you for watching this video. Thank you very much.